Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode we're going to take a closer look at multiple satellite launches using one rocket. So let's dive right into it. Now first you have to understand why the heck there is a need for that. Like one satellite is expensive enough that why do we want to do multiple satellite using one rocket? Now here's the deal. If you think satellites are expensive, a rocket is like hold my beer. Basically rocket, even the cheapest one, even the cheap Elon Musk one, basically $90 million or $120 million, they are very expensive. On top of that, rocket itself is the cheap part of the equation. The expensive part is getting the launch window, because you can't just launch a rocket whenever you feel like it. You have to get clearance from the government, you have to get the clearance from weather department, you have to get clearance from air traffic department. All those things combined, you always end up in a scenario where launch windows are very rare, very sparse. It's not like every day you can make a launch even if you want to. So first, that is the issue. Second, you have to get clearance from everything, from basically Coast Guard to marine life, everything. So all those things combined, they add up a lot of cost. So for that reason, not only that, even if you have infinite money, let's say you are from Dubai and you have infinite money, you still have to deal with the aspect of nature, because nature can be like, yeah, it's gonna rain, so you can't launch. Or it's gonna be like, let's say high altitude wind is too high, yeah, you can't launch. So launch window is very rare. We have to take into consideration. Basically, if you are launching one or two satellites, that's not a big deal. But if you are talking about a constellation where you have to make a constellation ready, let's say in 5 years, you cannot afford setbacks every launch. Then you have to understand, rocket basically did not evolve as our electronics did, because our electronics went from vacuum tube to transistor to silicon. So at this point in time, our electronics will be unrecognizable from electrical engineer from the past. But our rocket, they are literally the same. They are literally still liquid oxygen, liquid fuel. That's it, and you just pump it into an engine and set it as fire. Of course, our electronics on those puppies is also much more refined. The design language is much more improved. We have streamlined the process. It's basically refined, where our electronics has evolved on a different level. So the satellite that used to do spy missions, basically that can now be done by one smartphone. So you have to understand, because our electronics has progressed so much that our satellite can become now very miniaturized, basically like a CubeSat. One CubeSat is basically one U CubeSat would be 10 centimeter by 10 centimeter by 10 centimeter, 10 centimeter cube. So you can have 3U, basically it would be like 30 by 10 centimeter by 10 centimeter. And these are done for school projects. So understand this, like our electronics is that good nowadays, or college project. So what are the core considerations that you have to take into account before you just like, okay, I want to put 4 satellites? What do you have to consider? First, obviously the simplest one, mass, how heavy it is. And you don't only have to consider the weight of the fairing and satellite. You also have to consider the extra thing that now you have added in terms of base plate, separators, extra springs, extra pusher plates, all those. You have to consider that into the weight, because rockets are very intolerant when it comes to their weight. Basically, if you are sending it for 50 tons, it has only 50 ton capacity. It cannot do 51 ton. So they are very intolerant about that. So you have to take care of mass very carefully. You cannot be like, oh, I just thought I can add extra aluminum foil for electron shielding. Yeah, I added that to like 5 satellite, now the weight is out. So that happens. Then size, obviously, because there is a final limitation. This is the actual limitation of Falcon Heavy. Even if let's say you have a 20-ton payload that Falcon Heavy can lift, you can have a scenario where it may not fit inside the fairing, because Falcon Heavy fairing is basically size of a school bus. Some fairings are even bigger than that. So if you can fit it, then only you can send it. So you have to take care of the mass, then you have to take care of the size, then you have to care about center of mass. Now this is critical when you have generally something like this, where you have one main mission and then you have multiple small one can fail and your mission still would be classified as partial success. But when you are talking about like, let's say equal weight, basically let's say on constellation satellite where every satellite is the same, you have to take into consideration of center of mass, because rocket, while do they have engines which have gimbals in them, so basically the engine can go like this, they have limitation, and engines are designed in a very careful way, so they never exceed that limitation. So like let's say they can go 10 degree up, they will never go 10 degree up, they will only go to 8 to make sure for safety and emergency. So in those sort of scenarios, you have to take a very careful consideration about the mass, because you may have a scenario where you have like everything spread apart. Now that may allow you to put center of mass very center. That is awesome. But if it drifts for some reason, let's say you launched one satellite, or you're like at the last mission, hey, one satellite is not working, let's not launch it, let's launch with remaining, the center of mass could cause a rocket to fail. So you have to take into consideration that also. Then we come talk about orbital mechanics. Now this is the final nail in the coffin. Basically, if you have basically orbit direction, you cannot change that. If it's retrograde, it will remain retrograde. You cannot go prograde. So basically, if you are going clockwise, you cannot go anti-clockwise. So if your rocket is clockwise, your satellite will be clockwise. It does not matter whether it's 2 or 1 or 5 or 50. So that is the final thing you have to consider about orbital mech. You can change the angle, but not too much. Like let's say you have one rocket that is like this, and you want basically Earth, and you want to orbit like this, but you want to change it a little bit. I'm talking like 15-16 degree inclination you want to change. You can do that, but don't expect like, okay, I'm gonna launch in sun synchronous, then I'm gonna change it into another geostationary. You can't do that. Even if you have rocket fuel, it will take very long amount of time and very large amount of fuel tank. So these are the considerations that you have to take into account. Then we talk about delivery method. Okay, let's say you figured it out, you carried the rocket. How the heck you deliver it? It's not like there is one person, or orbit is like a train where you can like, okay, coach number 1, coach number 2, coach number 3. It's not like that. So we generally do 2 ways: very simple or very complex. Now you can simply have springs. This is an example of that. Now you have to understand, ISRO did something very amazing, and I will provide video link down below that you should see. When you have talking about spring launch system, they have an issue where if the satellite is launched, generally they are not stable. Basically they will be tumbling like this. So how do we balance that? Now that's up to the satellite. In CubeSat terms, they generally sometimes used to employ gyroscopes. Now they employ sometimes what we call electromagnetic suspension system. Basically your electromagnet would be arranged like this, basically 3 electromagnets perpendicular to each other. And because Earth has a magnetic field which is very strong at low Earth orbit, now it's not like it's extremely strong, it's just that in space you can use that practically. In geostationary is pointless. At best case scenario, you can detect there is a magnetic field. In basically low Earth orbit, you can send your electrical signal in such a way that it can align itself properly, or you can even use this for basically realigning your solar panels so they are always facing sun. So this is very commonly done, and it's very lightweight, efficient, and very good response time. So generally many of the high priority CubeSats generally employ that. Now sometimes you use pusher, like this is a ISRO's demo. Basically they were launching 2 heavy geostationary satellites in one go. So they had a basically separator in between, and that separator was not just a placeholder. Basically it had a small rocket itself, extra springs, extra hydraulics to make sure that the separation is done properly. So they are very complicated. Sometimes you may have a miniature rocket just there for extra satellite delivery. It has been done time and time again when you have to launch 2 big satellites from one rocket. So delivery mechanism can go from spring loaded to a freaking rocket launcher on top of a rocket. So you have to take into consideration that. Then we come to the aspect of current world record. Basically current world record is held by ISRO, Indian Space Research Organization. The mission is basically PSLV-C37. C37 is the designation. PSLV is basically Polar Satellite Launch Vehicle, and it was done on 15 February 2007, and the record is 104 satellites in one go, 100 plus satellite in one go. This is the world record. The nearest is not even half of this. So understand, that is like world record on a different level. And I already specified you cannot change the orbit once you have launched. So they have launched for sun synchronous orbit. Basically they launched this DoveSats. Now these DoveSats employ the same thing. Basically they have solar panel, they have electromagnetic system to orient themselves. Some say they even have gyroscope add-on. It could be anything like that, and using that they basically reorient themselves. So because if you see the video, I have provided the video down below, once they are being launched from the payload fairing, it's like they are tumbling like this, like crazy. So the reason this can still be used is because they have the mechanism to correct themselves. You have to have that. Without it, it's pointless. So the satellite has the ability to self-correct, self-align, and all that. It up to them, like whether they want to use electromagnets or they want to use gyroscope. So it's up to you. So you have to figure out a way to self-align, because if you can't self-align, you are just talking in thin air. It's not going to be any use unless you are throwing disco ball. Then we come to the future aspect. Now this is very necessary. When I'm talking about basically launching multiple satellites from one rocket, it's not a luxury, it is an absolute necessity for satellite internet. You can check my thorough detailed video about SpaceX Starline here, and the reason in that video I also go into the physics aspect of it. Many people are like, okay, satellite internet, satellite, how the heck it's gonna work? I have talked about in detail how that heck it's gonna work in that video. So TLDR of that would be, we need a lot of satellite. Basically that's it, we need to have hundreds of it. Now the smallest internet service provider that is even trying to do this global internet coverage is basically from 800 satellite. So you can understand that's a lot of satellites. You cannot afford to do that, like 800 launches. So what SpaceX is doing is basically this. this is 60 satellite packed closely together. Now these are half production. Basically they are production ready. The final satellite would be of the same size, but these are not ready satellites because they do not have laser link communication from satellite A to satellite B. They can talk from ground. That's it. That's all you can do. Talk from ground using radio. That will work. But basically this is just a placeholder mission. This is like they will do it. They will figure it out how it works and all that, because this, mind you, the Falcon 9 will set it into orbit, but after that it will be sent out using either spring or ejectors. So whatever they use, they have what we call a small ion engine. You can check my detailed video about ion engines here. Now that ion engines will orient it, because this satellites, because they are working in a much larger constellation and much higher density, they have to have very careful control over the orbit. So the way they are achieving that is using ion engines. And ion engines also provide another benefit, because low Earth orbit is very dense. Basically low Earth orbit, you have a lot of atmospheric particles. Now of course it's not enough to breathe or do anything with it, but it's more than enough to cause drag. Even International Space Station has to spend tons of fuel, like it literally burns through tons of fuel every year to keep itself oriented properly and to make sure it does not fall. So these puppies also have to do that because they are in low Earth orbit, and many of them would be below International Space Station. So the drag would be very significant. To make sure that drag does not cause the satellite to drop prematurely or uncontrollably, they will use ion engines. And this ion engine will also act as a basically self-annihilus. Basically at the end of the lifespan, or in case of a failure, the rocket will invert and fire, reducing the orbital velocity and then causing it to fall to the ground. And they have tested it that it will burn up in the atmosphere to 100%. Basically not even one piece, nut, bolt or anything will reach to the ground. So for this reason, that's why they are testing this using small ion engines. They will have magnetometer, but again this is the testing mission. They will refine all those things, and they're supposed to launch 60 basically launches per Falcon 9. That's why Elon Musk can actually pull this off at this point in time. Even right now, Starlink, they have figured it out, and they are like, yeah, they're gonna have 3 ground station, basically gateway, basically where the constellation will talk to the internet, quote unquote internet. They're gonna have 3 of that, and they're gonna have 5 million ground sphere, basically the devices that you will buy to put on your roof, or a small company will buy to put on their roof to connect to the satellite network. So all those things have been taken care of. The FCC regulation has been taken care of. All those hoo-has has been taken care of. But at this point in time, they have to launch upwards of 500 satellites to give a moderate coverage, basically rough coverage. At that point you will be like, you can connect to it, but it won't be very high bandwidth. But if you have more than that, let's say 800, you can do that. But you can understand, if you are launching 60 in one go, you only need basically 20 to 30 launches before you can cover the whole planet with basic internet. And its basic internet is still better than many ISPs, so understand this. So they can easily do this. Like they can only launch 20 of them, and given the fact that SpaceX has already proven they can launch 2 rockets in 1 month, it will barely take them few years. So their target is like in 5 years they should be have completely established the constellation. And the idea with that would be very simple. If the profit is not too high, they will not launch another. Basically they're supposed to launch 4,000 in lowest orbit, they can only launch 2,000 in that. So they will be like, they will keep adding as long as they are making profit. If they don't make profit, no problem. Like of course they will still have problem, because this is the bet of Elon Musk. If this project works, then they can afford the Mars mission. If this does not work, they cannot afford the Mars mission or even the BFR. So this is very important for the future. Now this was my presentation on why we use multiple satellite launchers, basically satellite in one launch system. I hope you liked it, learned from it. In that case, please leave a like. If you didn't like it, don't worry, you can press dislike. I would urge you to press this twice to show me your extra disappointment, and please leave a comment because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.